Questions 26 and 27 both deal with exponential growth and decay. And for that, we're going to use this equation, f of x equals a times b to the x. That's the general form for an exponential function. And a stands for, or a represents the initial value, and b is going to be the growth factor, what we're multiplying by in order to get the next number in the series. All right, so for this first one, we're dealing with the exponential decay of iodine-131, which is a radioactive isotope. It has a half-life of about 8 days. In other words, every 8 days, we have half as much of the substance as we had 8 days ago. And so for this function, we've got f of x equals, the question here says what percent of the original quantity will be left after 3 days. So since we're not looking for an actual amount of iodine-31, we're just looking for the percentage of what we had in the beginning. So let's just make our initial value 1, and then whatever we get will be a decimal that represents the percentage of what we had in the beginning. So we're just going to say our initial value is 1. So for our b, what our growth factor, or in this case our decay factor, what we have to multiply by to get the next number in the series, that's going to be 1/2. Whenever you're dealing with something with a half-life, just know that your b is going to be 1/2. But then we're not losing half of the value every day. We're losing it every 8 days. And so to incorporate that in here, we're going to divide that x by 8. So just kind of a tip for whenever you see something that's a half-life, this number is going to be 1/2, and this number here, the denominator up here in this fraction, is going to be the half-life. So here it's 8 days. If I were to give you the half-life of carbon-14, I think it's like 5,370 years or something like that, then that's what would go here, the 5,370. All right, and so we've got this equation. All we have to do is plug that into the calculator, and we're going to get 0.7711. And so that as a percentage is 77.11%. And that's answer A for 26. All right, now for 27, now we're talking about population growth. And we're told that the population is growing 0.9% per year. We're starting in 2000 when the U.S. population was 300 million. Sorry, 2006, the U.S. population was 300 million. So that's going to be our initial value, is 300 million. That's our initial value. And the growth rate is 0.9%. Now, the difference between growth rate and growth factor. The growth factor is what you have to multiply by to get the next number in the series. The growth rate is how much extra is being added. So if we're adding 0.9%, what we have to multiply by is 100.9%, because we still have the population we had before plus that little bit of extra. So the growth factor, what we have to multiply by is 100.9%. And we're going to represent that as 1.009. That would be 100.9%. And then to the x, where x is the number of years. And over here we're going to have 500 million. Because we want to know how long it's going to take to get to 500 million. So Now what we have to do is solve for x. That's going to tell us how many years it's going to take for the population to go from 300 million to 500 million at a growth rate of 0.9% per year. And to do that, since x is in the exponent, we're going to need a log to do that. So first thing we're going to do is divide by 300 million. And of course we have to do that on both sides. And now we're just going to get rid of all these zeros. These will divide to 1. And over here you're just going to have 5/3. Is equal to 1.009 to the x power. And now this written as a log, we're going to have log base 1.009 of 5/3 is equal to x. And then if we plug this into our calculator, log base 1.009 of 5/3, we're going to find that x equals 57. And then add 57 to 2006, because the 300 million population was reached in 2006. So if that's our initial value, our initial year is 2006. Add 57 to that, and we find that we'll reach the population of 500 million in the year 2063. So the answer there is A for 27.